Hello, welcome to another exciting Unity tutorial with me, Romy Fauzi. And in this video, we are going to create a RTS selections mechanism where we can just click and drag and then select all of the units that are inside of our selection. So I'm going to explain the concept behind it first. So if we press play here, we can detect the first click of our mouse and then the last click before we releasing our mouse. So for example, the first click are represented with the yellow cube here, and then the last click is also represented with the yellow cube. And we can create a virtual box here, and then with that box we can grab any object that lies inside of the box. So let's just do that. So now I'm going to create a new C# script and then call this box selection, and then let's open the script in Visual Studio. And now inside the box selection script we need to create a couple of private variables. So the first will be a vector3 type, and then let's just call this start position, and then the second one should be the drag position, and the next variable it will be the camera. So I'm going to create a new variable type of camera, and I'm going to call this cam. And then we also need a private variable type of ray, and this is for ray casting our mouse position into the scene or to the world. So inside the start method we are going to grab the first activated camera, so we can just type camera.main. This will grab the first object that has main camera tag. And then inside update we want to create a different mouse state. So the first one would be a input get mouse button, and then let's use the right click for selecting. So I'm passing 1 as the button index here, and then inside the get mouse button statement, if statement, we want to create another input get mouse button down this time, and this will be also the right click. And then here outside we want to create an else if statement, and this is for when we are releasing the mouse using get mouse button up. So let's just comment this code first. This is for when dragging the mouse, and this is on drag start, and this is for when mouse released. Okay, so we want to create a virtual box. We can use bounds in this example, but I'm going to create a custom class to hold our box data. So here outside of our if statement, I'm going to create a new public class, and I'm going to call this box. And I'm going to make sure that this class is serializable. So I'm going to add a system.serializable attribute. And we want to create a couple of a public variable. So let's just type public vector3, and I'm going to call the first one base minimum and the second one base maximum. So this will be the start click, and this will be the end click position, or the position while we are dragging. And here below we want to create a new properties. So let's just type public, and this will return also a vector3, and I'm going to call this center, and this is for getting the center of our box. So inside of this property we want to set a get value, and then inside this get value we want to return a vector3. So let's just create a new vector3 variable inside here, and I'm going to call this center with lowercase c. And here we want to take account the first position of our click, which is the base minimum. And then we want to add this with the base maximum position, subtract with the base minimum. So we are getting the direction from our minimum to the maximum position. And then we want to multiply this by half. So we get the center point from our minimum to the maximum base max. And then here below we want to override the y values with our base max, subtract with the base min, and we want to get its magnitude, but we want to also multiply this by half. So we will get the center of our height, and we are going to use this value here for the height of our virtual box here later in the size properties. So now let's just return the center vector, and we won't be having error anymore. And now the second one, we want to create a new public vector3 properties, and let's call this size. And we also want to return a size of our box here. So let's just type return new vector3, and we need to get the length of the x magnitude from our base minimum to the base max, and also the magnitude from our z, and also we want to set the magnitude as the height of our size. So we will be also putting the magnitude as the y values inside our vector3 here. And for the x, we want to type base max dot x subtract with the base minimum dot x also, and this would be the base max subtract with the base min, and we want to get the magnitude. And for the z value, we want to also subtract the base max z with base min dot z also. But this might produce a negative number depending on our start and end position, so we need to make sure that this value stays positive. So I'm going to run the absolute function inside the mathf class here. And for the z value, we also want to make sure that we are converting this to an absolute value using the mathf.absolute method, and we need to add a parenthesis here. Now we will have the size of our box, and then we also want to create a new public vector 3 properties, and let's call this extends, and this will be the value of our size in half. So it's quite easy actually. We can just return the size multiplied by half. So now we have created the box class here. We can start creating the code inside our update. Okay, so now we need to raycast our mouse position into our world position. And in order to do that, I'm going to feed our ray here with a function from our camera, and it has a screen point to ray. And for the screen point, we can pass the input.mouse position. And then we want to create a physics raycast method. Then we want to pass our ray, and we also need to pass our distance. So we can just put a very large number now. I'm going to put 100, and this is in units. And we also need to create a raycast hit variable here. Just create temporary one inside our if statement, and I'm going to call this hit. Here, before passing the max distance, I'm going to pass the raycast hit, but using the out keyword. So the resulting raycast will be saved in our hit variable here. And now here, when we start dragging, we can just feed the hit dot point, or the position of our hit, to our start pos, and then we want to start feeding the base min and the base max value here. So we need to create a new serialized field, and let's just type box for the type, and let's just call this box. And I've purposely set this as a serialized field so we can see the value in the inspector. So let's just type box, and then grab the base min and then pass the start position. And then when dragging, we want to set the drag position to our current hit point, and then set the box base max to the drag position. So basically the dragging is quite done. We need to expand this more later, but now I'm going to create a new method, a built-in method called onDrawGizmos. This is basically a method to draw gizmos in our scene here. First, I'm going to set the gizmos color to red. So let's just type color.red. Then I'm going to draw cube using the draw cube function, and it asks for a center and a size. So for the center, we can just pass the box center, and for the size, we can just pass the box size. Okay, let's save this. Let's get back to Unity and see this in action. So if we select the main camera here, we can go to the scripts folder and then select the main camera, and we want to drag the box select script to our camera. And you see we can expand the box serialized field here, and it has a public variable which is the base min and the base max. And now if I press play, if I enable the gizmo here on top of our game view on the top right, you see that we right drag, we have this cube. But we are drawing the wrong cube, so it should be draw wire cube. And if we try to drag, create a selection, you see that we are having a gizmos of box. So now the first step is done. We need to continue. So for the next step, we need to modify further our box selection script. And right now, let's create a new serialized field, and this will be a type of collider array. So I'm going to type collider array, and let's just call this selection. And now here, upon releasing the mouse, right click, we want to feed the selections array that we have just created with the method called physics overlap box. And this method basically find all colliders touching or inside of the given box. So if we open the parenthesis here, you see it asks for a center. So we can just type the box dot center, and then for the half extents we can type box dot extend, and this is why we create this extends properties to be used with the physics overlap box. And we want to also pass the default rotation quaternion.identity. And now let's save this. So here, back to Unity, let's try duplicate the unit, and then we can reposition the duplicate object. If we select the main camera again, you see now we have a selections array, and this is an array of collider. And let's save this. Let's try to run the scene here. And now if we if we right click and then drag the selection, if I release this, you see the selections will fill with the object that we just currently selected, and this is the unit one, and there you go. And if we select a multiple like this, you see it adds the other one, and if we select all of them, it adds the other one. So this is working very nicely, and we can use the selections to run a certain method from the unit. So I've already created the unit script here, and it has a namespace of RTS. So I'm going to convert this to the same namespace, and I'm going to call this RTS. And then let's just cut all of the script here below, including the public box classes here. And now if we cut this, let's put this inside the namespace area here. Save. Okay. So I'm going to explain a bit for the unit script, and I'm going to share the source code in the description. So basically the unit script, we have a list of material, we have a list of color, and this will save the original colors of the albedo color from our material. And on start, we are grabbing all of the child mesh render in the mesh render array, and then we also grab the Nav Mesh agent component. And for each of the meshes inside our meshes array here, we are going to loop through the mesh materials, and then we are going to store the materials from the mesh renderer to this material list. And then we also going to save the albedo color using the getColor method, and save this to the original color list. And whenever we run the selected method, we are going to set the color to red, and if it's not selected, or if the boolean that we are passing here is false, we are going to set this back to the original color. And we also have a public method for moving the unit using the agent component. So we are setting the new destination for the agent. Okay, so this is the unit script, and here when we release this, we can just run the method from the unit script. So let's just create for each loop here, and then let's just call this unit, and let's loop through the selection array, and let's create a new unit object, and let's call this unit. I'm going to rename this to obj, and let's grab the unit component from this each object inside of the selection. So let's just type get component, obj get component unit. And then we want to check if the unit is not null, then we want to set the unit selected to true, and we want to also store this unit inside a list, but we haven't created that. So let's just create a new private list, and the type should be unit, and let's just call this units selected, and let's initialize this new list unit. So now here, when we select the unit, we want to add this unit to the unit selected list. So let's just type unit selected add and then pass the unit game object. Okay, so now we have this setup. There is another thing that we want to do here inside the update. We want to create a new if statement for checking when we are pressing the mouse button down for the left click. So we need to pass a 0 as the argument. And here we want to check if the units selected count is greater than 0, then we want to loop through the unit here. So let's just loop through the units, and we can call this unit inside the units selected list, and we can just set the move unit to the click position. And now we need to also create a raycast head. So let's just duplicate this from this if statement and paste it here. And we want to pass the physics raycast inside of the if statement. So if the raycast is detecting that we hit an object and the unit selected count is greater than 0, then we want to run this method here. So let's just pass the hit dot point as the move unit position, and let's save this. Let's head back to Unity, and now we need to bake the nav mesh for our scene here. And if I open navigation mesh, I already baked this, but it's smaller than our ground, so I'm going to rebake this. But to bake this, we need to make sure that the cube or the ground is set to static. So I'm going to go back to inspector and then enable the static checkbox here, and back to the navigation and press bake. Okay, so now we have navigation mesh on our scene here. Another thing that I need to explain, that the unit is an object that has a navigation mesh and also a collider, and this collider will be detected by the overlap box function that we are running from the box selection, and the navigation mesh is being used by the unit script to move the object. So let's just test this out. And now if we right click and then drag, you see that we will be able to select the tank object. And here under the main camera, you see we have selected the collider of the unit 1 here, and also we added the unit component inside the unit list here if I enable the debug in our inspector. So I'm going to set this back to normal, and now if I click somewhere, you see that the tank is moving to that position. And if I select all of them and I click somewhere over here, all of the tank will be moving, but it will move to one point, a specific hit point. So there is this issue here, but this is for another topic. Let's stop this. And now for the last step that we need to do, we need to create an indicator of our selection in our scene here. So in order to do that, we need to use the projector from the standard assets. So if you go to the asset store, standard assets, and then just import this, but you don't need to import all of them. And when importing here, just unselect all of them and then go to the effect subfolder under the standard assets. There is an effect folder, and here we have the projector, so you can just import this projector. I've already done that, so I don't need to re-import this. And here inside the standard assets under the effects folder, I have the projector folder, and we have a prefab. So I'm going to drag the blob light here, and then I'm going to unpack this prefab, and I'm going to rename this to projector. And for the material, I'm going to use a custom material that I've created. I found in another video. I'm going to put the link to that video, and this shader is basically asks for a texture, and also we can define HDR color. So by selecting the projector, I'm going to add this custom projector as the material, and we need to modify our box selection script. So let's just disable the projector first, And then let's go back to Visual Studio. Under the box selection, I'm going to import the standard asset namespace here. So let's just type Unity standard assets, and I'm going to access the effects library, and let's create a new serialized field. Let's access the projector object, and let's just call this projector. And here, if we go back to Unity and select the projector, you'll see that we have a couple options. Under the projector component, you see that we have a couple of settings or parameters. I'm going to check the orthographic size, so it's orthographic, our projection. And let's just enable this so we can see our selection. And this is the shader effect. If we move this, and we can change the size, orthographic size, and also the aspect ratio here. So for the orthographic size, we need to convert this value, the aspect ratio and the orthographic size, to follow our box size. So in order to do that, aspect ratio is basically the width divided by the height of a size or dimension. We get the aspect ratio, and the orthographic size is the height divided by 2. So with that in mind, let's go back to the script here, and we already have reference to our projector. Now, whenever we start dragging, we want to enable the projector. So type the it should be projector. So I'm going to rename this, and let's access the projector, and then type the enable to true, or we can just set this here when we first click or we first dragging, so it doesn't get executed every frame when we hold the mouse. And when we release the mouse, we want to set this to false, so it will get disabled. And now when we are dragging the mouse, we want to set the size of our projector. So let's just access the projector aspect ratio, and then we can access the box size dot x divided by the box size dot z. So we are dividing the width and the height of our box, or the depth, but we are converting this depth as a height for our projector. And then we also want to set the orthographic size to the size of our z size multiplied by value of half, or divided by 2. And the last thing that we want to do is we want to set the position of our projector to be on the box center. Okay, save this. And now if we go back to Unity, we should disable the projector first so it doesn't get drawn or activated, and save the scene. After disabling the projector, we want to select the main camera and then drag the projector object to the slot projector of our box selection script here. So save this and then press play. So now if we try to right click and then drag this, you see that we have a projection on our scene. So now with the gizmo disabled, we can see our selection area. So if we select the tank here, you see we are selecting all of them, and then it changed color. And then if we press click, we can move the tank. And the selection does not get clear, but we can create a function just to do that. So here, inside the release mouse here, we can clear the selection by looping through our unit, and loop through our units selected, and then set the selected value here, and then pass false as the value. And after that, we can clear the units selected list, run the clear method for the units selected list. And here below, we want to add a check if the box size magnitude is less than 0.1. It's a very small value. It means that we are barely dragging. Then we want to return the method. So with this here, you see that if I go back to Unity and then press play, if I select this and then I want to clear this, I just can select right click anywhere on the scene and it will get cleared. So this is how you create a box selection for moving units on an RTS game. I hope you find this tutorial useful, and if you like the video, please hit that like button and hit subscribe. Thanks a lot for watching.